Hello viewers, welcome to a new lesson in iTTV. Are you ready to begin this lesson with me? This lesson is the start of another chapter in the Form 4 Additional Mathematics syllabus. We are talking about Chapter 3, which is entitled Quadratic Functions. Specifically, we will start with discussing quadratic functions and their graphs. Firstly though, viewers, we need to understand what a quadratic function is. So let's begin with a definition of quadratic function. Recognizing quadratic functions. A quadratic function is a polynomial function of the form f(x) equals to ax squared plus bx plus c, where a is not equal to 0. Do you understand what the word polynomial means, viewers? Well, a polynomial refers to a sum of powers in the variable. For example, x to the power of 2, x to the power of 3, and so on and so forth. And these variables have been multiplied with coefficients. So, to put it all together, a polynomial is a sum of powers in the variables multiplied by coefficients. In this particular chapter, we're dealing with polynomials where we only have one variable, which is x. Let's move on. Ax squared plus bx plus c is the definition of a quadratic function. It is also known as the general form of a quadratic function. And it is a polynomial of degree 2 or second order because the highest power of x is equal to 2. Now, viewers, do take note of that. It is important to remember that a quadratic function is defined because the highest power of the variable is 2. Let's look at an example next, shall we? In this example, determine whether each of the following is a quadratic function, and hence write it in general form if it is. These are the functions. A, fx equals to 3x squared minus 1. B, g of m is equal to 1 over m squared minus 2m plus 4. In C, we have h of t, which is, in brackets, 2t minus 1 squared minus 3 into t plus 1. And part D, we have ks equals to s plus 1 over s plus 2. And in part E, we have L of w, which is 4w minus 3w squared. Now, it is worthwhile to go to the board now and discuss these functions in detail. Well, viewers, let's apply what we have been discussing so far to determine whether these 5 functions are quadratic functions or not. A. We notice that fx contains 3x squared minus 1, and the square is the highest power of the variable x in this expression. Hence, it is a quadratic function because its highest power is 2. And how do we write it in general form? Remember, general form is ax squared plus bx plus c. And since there is no x term here, we ought to write it as plus 0x minus 1. That's the general form of the function of x. Part B. Gm, however, you notice is an algebraic fraction, and that makes it not a quadratic function at all. So our answer for B is no, it is not a quadratic function. That's because it is an algebraic fraction. Do take note, however, that the reason why Gm is not a quadratic function here is because the algebraic function is the denominator. If, on the other hand, the algebraic function is the numerator and we have a constant as the denominator, it would be a quadratic function after all. How about part C? ht is made up of an expression which has not yet been simplified. If we expand the expressions in there, we find that we will be able to obtain an expression that contains t squared. Let's try it out together. ht is 2t minus 1 squared minus 3 into t plus 1, and therefore when we expand it we get 4t squared minus 4t plus 1 minus 3t and minus 3 as well. Upon simplifying, we observe that we do have a quadratic function because the power of t is only up to 2. So the answer for whether it's a quadratic function or not is a yes. Part D. In Ks, it contains, firstly, no variable with the power of 2, and additionally, the term 1 over s means that the power for s in that term is negative. So, because of these two reasons, Ks is not a quadratic function. Let's put that down over here. Firstly, it is not a quadratic function because it does not have any s squared term. And secondly, because the power for 1 over s is negative 1. Lastly, what about the function in part E? Lw is 4w minus 3w squared, and it fulfills the condition of having the highest power for the variable to be 2. So, yes, Lw is a quadratic function. And in general form, we would write it as ax squared is the general formula for a quadratic function. So in this example, we apply it where the x has been replaced with w. So we should write it as negative 3w squared, followed by the term containing w. And because there's no constant term in that function, we should write it as 0. This is the general form for the quadratic function in part E. Now that we have understood how to recognize quadratic functions, let's move on to how we should plot graphs of quadratic functions. What do we need when we want to plot the graph of a quadratic function? Well, surely, firstly, we will need graph paper. But more importantly is how we present the graph on that piece of graph paper. Well, in the first case that we are going to look at, we will be given a table of values, and from there, we're going to sketch the quadratic graph. Do take note, however, that when you want to plot the graph of the quadratic function, you need to make sure that you have a set of uniform scales on your graph paper. This is the graph paper that we will be using to plot the graphs of quadratic functions in a short while. And in fact, viewers, this is the same type of graph paper that will be supplied by the SPM examination of the additional mathematics paper. Do observe that we have a scale of 10 small boxes, which takes up 2 cm, and this is what we shall base our scale on. If, for example, the range of values given to us is small, it would be a good idea to use 2 cm for every 1 unit. For example, here, -2, -1, 0, 1, 2, 3, and so on and so forth. However, if your range of values is large, you might want to consider using just 1 cm for every single unit. For example, make this a 1, 2, 3, 4, 5, 6, and so on. Well, let's move on to the slides now and explore our first example where we are going to plot the graph of a quadratic function. Plotting the graphs of quadratic functions. Case 1, based on given tabulated values. In this example, you see a table of values given to you where x ranges from -2 to 4 and fx ranges from -5 to 4. Let's go over to the board to see how we are going to plot this graph together. Right, viewers, here is the table from our first example, and we would like to start right from the scratch how to plot a graph of a quadratic function. You notice that the Values of x range from -2 up to 4, and that will help us to determine how we're going to draw the scale onto the set of axes that has already been given to us. Since -2 to 4 is a range of approximately 6 units, we must make sure that there are at least 6 units on our x-axis. A little bit more would be even better, because then it gives you a little bit more space on both sides of the axis. So if 0 is right at the origin, I should then label this to be -1 and -2 respectively, followed by the positive values for x from 1 till 4. 3, 4. So there we have it, 1, 2, 3 and 4. The same goes for your y-axis. Ensure that you have enough space to cover all the positive and negative values that the table contains for the y-axis. From 4 down to -5 indicates a total range of approximately 9 units, so we must make sure that we have enough squares for that scale. -1, -2, -3, -4 and -5, followed by the positive values which go up to 4. That takes care of our scales. Now we're ready to plot the points onto this graph paper. As x is equal to -2, y equals to 4, hence we will search for that point, meaning -2 and 4 brings us to this location. So we will plot point by point onto this graph, and then we will draw a smooth curve to connect all the points. And that's basically how you plot your graph. So -1 to -1 is down here. 0 and -4 brings us down to here. And then we have 1 and -5, which is over here, followed by the remaining 3 points. 2, -4 is 2 and down 4 units. 3 and -1 means move to the right 3 and move 1 unit down. And finally 4, 4 brings us to 4 units right, 4 units up. It takes a little bit of practice, viewers, to make your curve as smooth as possible, but as you practice, you will gain more confidence when you're drawing your graph. And there you have it. This is the way that we will draw a graph given a table of values for our quadratic function. Let's go back to the slides and look at another example. Well, viewers, we've just completed an example where we were given a table of values, and that enabled us to plot the graph of the quadratic function. What happens if this time we are given the function instead? We will see what we're going to do in the next example. Plotting the graphs of quadratic functions, case 2, where we need to construct the table of values. In this example, we are given the quadratic function f(x) equals to x squared minus 3x minus 5. Plot the graph of the function for -3 to 5 for the values of x. What is the procedure for plotting the graph of this quadratic function? Well, we need values of x and y to be able to plot the graph. So the first thing we must do is to construct a table containing the values of x and y for this function. To do that, let's move over to the board to begin this solution. Right, the function that we've been given is f(x) equals to x squared minus 3x minus 5, and we need values before we can plot the graph. So we are going to construct a table of values for this function. We should know by now how we're going to find the y values, but let's work it out together. When x is equal to -3, which is the lower boundary given to us in the question, We need to replace negative 3 into the function in order to get the y. And therefore, let's begin with calculating f of negative 3. We find that we have negative 3 squared minus 3 times of negative 3 minus 5. And therefore, you get your 9 plus 9 minus 5, giving us 13. So this value 13 goes into the table. Let's just try another one just to make sure that we're fully understanding what the procedure is like. Shall we take, say, x equals to 4? These are various examples that we're looking at. When x is equal to 4, again, we're going to replace it into the function. So we get 4 squared minus 3 times of 4 minus 5, which gives us 16 minus 12 and minus 5, which is negative 1. That goes into here, and in the same way, we're going to complete the rest of the table. Right, let's bring in the graph paper and we will proceed to draw the graph. Now that the table of values for x and y is completed, over here, we're ready to draw the graph of this quadratic function. If you recall, we need to make sure that we have a uniform scale and it's properly drawn on our paper with sufficient space on both the x and y axis and on both the positive and negative sides. From the table, the first set of values we have are x equals to negative 3 and fx equals to 13. That will bring us to this point, which we will mark with a little cross. And in the same way, we're going to plot down all the other points as well. So the next point from the table was x is negative 2 and y was 5, giving us this point. As you proceed with the rest of the values, you are going to get the remaining points that have already been shown on the graph here. And then you use your pencil to connect all the points in a smooth curve, which will then produce this quadratic graph that was given to us in the question. Now don't forget that we should label the graph, so the function that was given to us, x squared minus 3x minus 5, should also be written when you've completed the graph. Do take note that although the two lowest points have the same y values, they cannot be joined by a straight line parallel to the x-axis because this is a graph of a quadratic function which has either a concave up or a concave down shape and not a straight line. So you'll find, viewers, that with a little bit of practice, you will be able to become very confident and draw quadratic graphs very smoothly. So do try your best and do practice a lot on this. In this lesson on quadratic functions, we have firstly learned to recognize what a quadratic function is, and then we have learned to plot graphs of quadratic functions. We explored two cases. In the first case, we were already given the table of values and hence we straight away plotted the graph. And in the second case, we were given the quadratic function where we had to construct the table of values first before we could draw the graph. Well, I hope you have enjoyed and understood this lesson on quadratic functions, and I hope also that you are determined to practice hard and revise a lot so that you'll become very confident and very clear on the lessons in quadratic functions. Thank you from iTTV.